Hello, Geometry. A little late to the game with this video, but that's okay. At least it exists. At least I'm getting to it. We're doing lesson 5.1. It's the start of our parallelogram unit. Last unit, we were looking at triangles quite a bit. Today, we're looking at, with this unit, we're looking at parallelograms. But guess what? Triangles aren't going away because parallelograms are essentially created by triangles in a unique, interesting way. So let's follow step one here. Make a quadrilateral by rotating 180 degrees around the midpoint of BC. So here's the midpoint of BC. And this is a bit of a throwback to our transformations unit. Rotate this triangle around this point 180 degrees. So that's what we're going to do. We're going to rotate triangle ABC, okay? So here's triangle ABC. I want to try to get this to lock in place. Okay, why does it hate me? A, B, C. There we go. Good enough. And so we are going to rotate this 180 degrees. I'm going to do my best here to rotate this with my fingers here. And a full rotation of 180 degrees is going to end up right. I made it a little small as I rotated, so I'm going to match it up the way it's supposed to. Oh my gosh. Right there is what would have happened. Okay, you see how I turned it? Right, bear with me. We're in this technological world here. That is our now. Take a look at that. It's a quadrilateral, right? 1, 2, 3, 4-sided shape. Of course, it's a quadrilateral. Okay. So when I did the rotation, dang it. When I did the rotation, let's see where everything matched up, right? This is A, this is B, and this is C, right? Oh, now I can't click on the shape. Oh, crap. So our A value, oh my gosh, hates me today, eh? All right, I can't handle that. So this was A, and A prime went up here, right? Right, that's what A prime is. However, our drawing is asking that we call it D. Okay, so this is D. So this point, let me use colors here. Right, I hopefully I probably don't even need to explain this, but this point matches up with D, and then B rotated around and went to C, but then C rotated around and went to B, right? The way it swiveled. So what I'm saying is this angle is the same as this one, and this angle is the same as this angle, and this angle is the same as that one. You with me? Right? The way we rotated it? Also, speaking of, right, this side rotated up to this side, and this side rotated around to this side. So we've created a four-sided shape with some really interesting properties. So what do we know? AB is congruent to DC, and BC, of course, is congruent to itself. And we know that AC is congruent to DC, or DB, sorry. And then angle 1 is congruent to angle D, right? Angle 2, which is right here, is congruent to this angle. How do we name that? That's angle BCD. And then angle 3, which is right here, is congruent to this angle up there, which is CBD. And then we know that B to M, which is our midpoint, is going to be congruent to M to C, of course, because it is the midpoint after all. And then actually, something that happens is that A to M is the same as D to M. So soak that in, right? These sides are congruent. These sides are congruent. This angle is congruent. These angles are congruent. These two angles are congruent. And also, because M is the midpoint, this half is congruent to this half. Also, this half is congruent to this half. Lots of congruency happening there. Why are the opposite sides of the quadrilateral parallel? This is a parallelogram after all, that I'm trying to show you here. And we want to look at this and determine why are the opposite sides parallel. You might look at this and go, well, they look like it. And I'm glad that you think that, right? That this side and this side will never intersect, right? They're going off forever at the exact same slope. They're never going to touch. In this top side and this bottom side, that's going off forever and it's never going to touch, right? They look parallel, but why exactly are they parallel? Well, I like to think of this because, well, we have alternate interior, or we have, alternate interior angles. Take a look at this side, right? What if I just, okay, ignore all of my drawings here. Here's the bottom side, here's the diagonal, and here's the top side. Here's angle 3, and here's that top angle. Look at that. I think it's crystal clear now, right? This, because we have alternate on opposite sides of the transversal interior angles that are congruent, therefore they must be parallel, right? That only, do you remember that angle relationship, hopefully, right? Because we have congruent alternate interior angles, our sides must be parallel. They must. And if you looked at my drawing the other way, right, and you said, well, that's only the top and bottom sides. Well, if you look at this side and the diagonal and this side, well, I said angle 2 was congruent to this angle up there. And, tilt your head a little bit, right? Take a look at it, right? We have alternate sides in between the lines. Boom, alternate interior. Why are the consecutive angles supplementary? That question is asking us, when you look at your four-sided shape, why is this angle and this angle, why are those two angles adding up to 180 degrees? Well, I'd argue because they are consecutive interior angles. Do you remember that one from parallel lines, right? If you have two parallel lines and a transversal, the angles on the same side of the line are going to be supplementary. Well, that's exactly what we have here. We have two, we just proved them to be parallel, didn't we? So these are parallel lines. This is our transversal. These guys are on the same side, consecutive. And what do we call this parallelogram? Or what do we call this quadrilateral? A parallelogram. All right, I'm going to spend less time on this second one because we're doing the exact same thing. We're doing the exact same thing, except now we're just rotating it around a different point. So when I rotate this guy 180 degrees around the midpoint of AC now instead, I almost just cussed. I'm so mad at this thing. Uh, there we go. There, we end up with a shape like that. Now, please don't look at that and tell me that it's a rectangle. Okay? It is not. All right? A rectangle has to be 90 degrees. We do not know if this is a 90-degree angle. We just don't. In fact, I'd argue that it looks like it's not a 90-degree angle. That, to me, that looks just a little bit wider than 90 degrees, maybe like 100. Okay? So this is not a rectangle. It's close, but it's not. All right? Everything we just said up there is going to be true here as well, right? AB, as this rotated around, is going to be congruent to DC. BC, as this gets rotated around, is going to be congruent to DA. And AC just ended up on top of itself. Angle 1, as it got rotated around, is going to be congruent to this guy over here, which is angle DCA. D to C to A makes that angle. And 3, as it gets rotated around, is going to end up right there and congruent to D to A to C. And angle 2, as it gets rotated around, is going to be congruent to angle D. And everything we said about the diagonals is exactly the same here. B to M is going to be the same as M to D. And A to M is the same as C to M. Now, what did we end up with here? We end up with a drawing that has similar qualities but doesn't quite look the same. However, right, if you really zoom in on it here, right, if you really think about it here, we basically have the same drawing. Here's my zigzag, right? Oh, angle 3 and that guy. Yep, they're congruent. We once again have parallel sides. Or take a look at it this way. Boom, boom, boom. Angle 1 and this angle right there. Yep, we have alternate interior. So, same as above. Same as above. We once again have a parallelogram. It looks different, but because it was generated by a rotation, it has the exact same qualities. So, what if we rotated around the midpoint of AB instead, right? We rotated around this point and we rotated around this point. Well, what if we rotated around that point? Guess what? We're going to get the same crap. We don't need to do it again. What's going to happen? Our opposite sides are congruent. Our opposite sides are parallel. Our opposite angles are congruent. Our consecutive angles are supplementary, and the diagonals have been bisected. Right? That's everything that we were saying. This side is opposite, and they're congruent. This side is opposite, and they're congruent. This diagonal got split in half, so it's been bisected. This angle is opposite of this one, and they're the same, right? It's what we've been saying. So these are the big boy facts about parallelograms, and just sink it in, right? Opposite sides congruent. Opposite sides parallel. Opposite angles congruent. Diagonals bisect. Right? Those are the big facts. All right, real quick, last one. What if we reflected? Just what if, right? What would the result be? Well, B would reflect right across to here, and we'd end up with this shape. So it didn't turn, it just flipped directly across, right? So we know that this angle is the same as this one, and of course this angle is the same as that one, and this angle is the same as that one. So it didn't turn, it just flipped across. Well, we don't really have opposite sides congruent here, do we? We have kind of consecutive sides congruent, one right after the other. So I would not, this side is opposite of this side, and they're not congruent, okay? This one is congruent with this one, and this one's congruent with that one. So what can we say here? AB is congruent to BA, and BC is congruent to, well, I guess I probably shouldn't call that B, should I? Should call that D, like I was in the previous drawings. That's my bad. BC is congruent to DC. I'm gonna, if this is straight across, well then that is perpendicular, right? When you reflect, you go straight down, straight across that line of reflection. So actually your diagonals from B to D and your diagonal from A to C, when they intersect one another, it's going to be perpendicular. And we write that using this notation. BD is perpendicular to AC. I kind of skipped the angles. Angle 2 is congruent to angle ADC. Angle 1 is congruent to angle DAC. And angle 3 is congruent to angle DCA. Hopefully at this point we're pretty good at naming angles, right? If that's 1, well then this guy is D to A to C. And here's angle 3, it's congruent to this guy, which is D to C to A. There are none. Unless you want to count the diagonals. But I'm not going to worry about that. What type of quadrilateral was formed? This is called a kite. And if we were to list some properties about kites, similar to what we did up here, the bisectors are perpendicular. There is only one set of congruent angles, right? If you draw this shape like this angle is congruent to this one, but this one is not congruent to that one, right? So we only have one set that's the same. In our parallelograms, this was the same as this one, and this one was the same as that one, right? The opposite angles are congruent. In a kite, that doesn't happen. There's only one set. And then two sets of congruent sides. This one and this one, this one and this one. All right, I tried to make it quick. I think we did it quick. It was under 20 minutes. Very visual here, like no math, right? If you just need to see me turn that object again, if you just need to see how things are matching up, just pause and stare at the picture. Not a lot of math. Very visual here. So hopefully we feel good, and hopefully the classwork will be easy. Thank you for watching.